Hello everyone, welcome back to your YouTuber teacher Miss Pamela, and let's continue working with simple machines problems. I hope you are having this stuff clear, but make sure to clear doubts with me. In any doubt you have, you can look for me. Anyway, next session we'll have a Zoom meeting where we clear doubts about it, okay? Because next week, Wednesday, we're having an exam. Okay, let's start talking about levers. Remember, in another video, I said before that there were 3 different classes or types of levers. Type 1, type 2, and type 3. Or class 1, class 2, and class 3. Now let's start with this one. Okay, important terms that we need to know. We have effort or force. You can also find that word in the problems. Load or resistance. And pivot or fulcrum or application point. Okay? I like or I prefer to use the application point. Okay? But any of them will be correct. And now let's remember that a lever in Spanish is a palanca. Now, the first class lever, guys, has the application point in the middle. Okay? I even have like a tip for you if you want to learn them. We have this one would be far or ref. Okay, with the application point in the middle. Far or ref. You can have it the other way around. Now you have then the second class lever, and in the second class lever, the application point is in one side and the resistance is in the middle. The force is in the other side. So this one, you can learn it as ARF or FRA. The R is in the middle. And in the third class lever, we have the force in the middle. The resistance in one side and the application point in the other side. So this one, I call it AFER or IRFA. Okay? So these are the 3 classes of levers. Now, in the next tables, if you read the instructions, it says, in the charts below, insert 2 images of other examples that you find in Google corresponding to the class of lever. Mark the effort, the force or effort, the fulcrum or application point, the resistance or load, any word, on each one. I put 2 examples of each, and then you'll put another example here and another example here. Let's analyze the first class lever. In here we have a hammer, okay? And now, the claw hammer is used to pull out a nail, okay? Now, the effort force, or your hand, will be right here, okay? Then you have the load, or resistance, which is the nail, and the fulcrum or application point is right here. Now, it's important for you guys to understand that in the problems, you need to know these 2 concepts. Levers have arms. Yes, arms like us. Okay? One of the arms has to do with the force and the other one with the resistance. And we call them A and B. A has to do with the force, it's the force arm, and B is a resistance arm. Okay? Now, how will I notice which one is which one in the problems? Well, the distance from the center to the resistance will be letter B, because it's the resistance arm. It's the one related with the resistance. And the distance between the center and the force would be the effort arm, or the force arm will be letter A, okay? We'll see it later on. Now, another example would be scissors. The load, or the object that you want to move, in this case is a piece of paper, the fulcrum or application point, and the force is applied right here. Now again, search for these images. 2 examples, and name the three different parts of a lever. So in the second class lever, we have, for example, a bottle opener. In this one, we said that the resistance or the load is in the middle. So imagine here you have your bottle, okay? This is in the middle, and you can see the picture is kind of tricky, but if you think about a bottle opener, here is where the force that the pivot or the application point is applied on it in order to open it. So it's right here, and here will be the force. Or a nutcracker. The application point is in this side. The object that you want to move, in this case is the nut that you want to crack, is in the middle. And the force is applied right here. Please find two images. And then we have third class lever. In the third class lever, you have, for example, the tweezers. The tweezers, here is the object that you want to move. Here is the force that you are applying, and the application point is in one edge. The staple remover, the same. The staple goes right here, the force goes right here, and the fulcrum goes right here. And these are the three classes of lever that you need to understand. Please do two more examples. Okay, and from there, I will just go to my problems. Let's start with the first one. A claw hammer is used to pull out a nail. The resistance arm is 4 centimeters and the effort arm is 47 centimeters. Find the resistance if the effort force is 145 newtons. And this is what I was telling you before, guys. Here we have the example. We know that the application point is right here. The distance from here to here is the force applied because we can see the hand right here. And the distance from here to your object, the object, which in this case is a nail, is a resistance. So we said that this one would be letter A and this one would be letter B. Now, in order for a lever to work, letter A needs to be always bigger than letter B. Because imagine, let's say, we already said that this one is letter B, but imagine this one is bigger and this one is shorter. Well, your hand will be right here, and it would be super difficult to move it. That's why letter A, or the effort arm, where the force is applied, needs to be bigger. Okay? We'll see how it works with a mechanical advantage in that part. Okay? So let's start putting our data. In all of our simple machines, problems, we've learned that we always have resistance and force. And in this type, if you remember, in the inclined planes, we have length and height. And now in this one, we'll have A and B. Another tip for you guys to remember the A and B's is that if you see it alphabetical order, A goes before B. So F goes before R. So A goes with F and B goes with R. Okay, I hope it helps you. These are the PAME tips. I'm joking. Okay, so we have a resistance arm of 4 centimeters. So we're talking about, if you see it, you have 4 centimeters and 47 centimeters right here. So if you observe your image, where would you put the 4 centimeters? Where? Well, right here. And the 47 centimeters right here. Okay, so we said this one is B and this one is A. So let's write it down. 47 centimeters and 4 centimeters. They're asking me to find the resistance, so we want to know the resistance, which is a nail, question mark, with a force applied of 145 newtons. The formula we will be using in this case will be force times A equals resistance times B. So we're searching for resistance. It means that I am bringing my letter B to the other side. As we know, if it's multiplying, we will bring it here, dividing. So we have resistance equals 145 newtons times 47 centimeters divided by letter B, which is 7 centimeters. The unit that will cancel is centimeters with centimeters. So your resistance will be equal to 145 times 47, 6,815 newtons divided by 7. You have a resistance of 973.57, or if you put a 6 or a 5, I'll put it correct. And the answer will be given in newtons, because remember, if I give you newtons, you give me newtons. And this is your answer. Now let's find the mechanical advantage. Mechanical advantage of a lever will be A divided by B. So A equals 47 centimeters divided by 7 centimeters, 6.7. Remember, we do not have a unit. Okay, let me do number 3 with you guys. Try to do number 2 by yourselves. A rock of 60 kilograms rests on the end of a 2.5 meter lever and is 1 meter away from the application point. What force must be placed on the other end to balance the lever? So let's check this one out. If you want to draw your lever here, they're telling you that your lever measures 2.5 meters, okay? And 1 meter, let's say right here, is the application point. So they're telling you it's 1 meter away, a 60 kilogram rock. So you have 60 kilograms here of a rock. They want to know what force must be placed on the other end. So how much force you need to apply right here in order to balance this lever. Now, this one will be letter A. This is the longest one. And this one, where is the resistance, is letter B. Okay? So if from here to here measures 1 meter, it means that from here to here measures 1.5 meters. Right? Tricky, I know, but it's easy if you read it again. So, if you have force and resistance like always, A and B. The resistance is of 60 kilograms. Letter A is of 1.5 meters and letter B is of 1 meter. We're searching for force. If we know that force times A equals resistance times B, and we're searching for force, it means that letter A, I'll pass it to the other side, dividing. So I have force equals 60 kilograms times 1 meter divided by 1.5 meters. I will cancel meters with meters, and your answer will be in kilograms, because remember, if I give you kilograms, you give me kilograms. So you have 60 divided by 1.5 equals 40. And now you measure your mechanical advantage. Mechanical advantage equals A divided by B. So mechanical advantage equals 1.5 meters divided by 1 meter. Mechanical advantage equals 1.5. Here's your answer. And here's your answer for mechanical advantage. Okay? I believe you can do number 4 by yourselves. And now, let's start with the wheel and axle problems. In problem number 5, it says, what is the mechanical advantage and the resistance of a wheel and axle if the wheel has a radius of 45 centimeters and the axle a radius of 5 centimeters with a force of 35 kilograms? Okay, it's important for you to know or to remember that in this type of problems, we're talking about wheels. So we already know that a wheel is round. Yes? And because it's round, we know that it has a radius. Okay? Lowercase r, I'll put. And the axle is a small one. It's in the middle. Okay? So, like all of our simple machines problems, we have force and resistance, radius of the wheel, and radius of the axle. This is the variation. we have, and they're also asking me for mechanical advantage. So I have 45 centimeters and 5 centimeters. 45 centimeters, the wheel is always greater than the axle. So we have 45 centimeters and 5 centimeters. And a force applied of 35 kilograms. We're searching for resistance. So in this one, we will have force times radius of the wheel equals resistance times radius of the axle. We're searching for resistance. So we will bring radius of the axle to the other side, dividing, because it's multiplying in the other side. So we have resistance equals force, which is 35 kilograms, times 45 centimeters, divided by 5 centimeters. Here I forgot to put the C. So resistance equals, we cancel centimeters with centimeters, and 5 becomes a 1, 45 becomes a 9. So you have 35 times 9, 315 kilograms. And your mechanical advantage will be radius of the wheel divided by radius of the axle. Mechanical advantage equals 45 centimeters divided by 5 centimeters. Cancel centimeters, and your mechanical advantage is of 9. Okay? I will do the next problem with you guys as well. A doorknob has a 45 millimeter radius. The radius of the axle is 4 millimeters. Find the mechanical advantage of the machine and the force used if the resistance is 78 newtons. Okay, so in this one, you have here the wheel, and here you have the axle. Okay, so we have force and resistance as always, radius of the wheel, and radius of the axle. Force, well, they're giving you 45 millimeters and 4 millimeters. So radius of the wheel, 45 millimeters and 4 millimeters. And you have a resistance of 78 newtons. We're searching for force. Force times radius of the wheel equals resistance times radius of the axle. We're searching for force, so it means I'm bringing radius of the wheel, dividing to the other side according to our rules. So we have force equals 78 newtons times 4 millimeters divided by 45 millimeters. We cancel millimeters with millimeters, and we have 78 times 4. 312 newtons divided by 45 equals 6.9 newtons. And then you find your mechanical advantage, equals radius of the wheel divided by radius of the axle. 45 millimeters divided by 4 millimeters. Mechanical advantage equals 11.25. And these are your two answers, okay? Try to do number 7 by yourselves. Try to upload them today. And anyway, I will be in classroom waiting for any doubt or whatever you need. And tomorrow we'll have our session to clear some doubts. I miss you. I send you a lot of hugs, virtual hugs, and see your happy faces tomorrow. Love you guys. Bye.